On the 2nd of September 2023, India launched its first space probe to study the Sun. This solar mission is called Aditya L1. It's going to travel almost 1 million miles and join 4 other spacecraft that are currently circling a point in space known as Lagrange Point 1. But this Indian mission is different from the rest. How come? Experts call this mission a unique observatory, all because it combines instruments that can shed light on not one, but on 3 crucial questions. The first one is how stars like our Sun sustain their insanely hot outer layer. The next mystery that confuses scientists is how exactly the Sun's magnetic field produces such severe solar storms. And the last one is how the variations in the magnetic field of our star affect the atmosphere of our planet. Aditya L1 has 7 instruments that can help observe the layers of the Sun. For example, with the help of electromagnetic and particle detectors, the probe will examine the Sun's corona, which is the outer layer of the star. While doing it, the spacecraft will be hovering at a safe distance from the Sun, around 92 million miles. Researchers hope that the mission will be able to gather data on the properties of the corona and figure out what causes coronal mass ejections. Those are enormous bursts of electrons, ions, and magnetic fields. The probe is also expected to examine the Sun's lower atmosphere and the boundary between the atmosphere and the interior of the star. Everyone is waiting for the data from the mission with bated breath, especially from its Solar Ultraviolet Imaging Telescope. No wonder, it can help to study solar winds and the way they accelerate, as well as coronal heating. This telescope can also potentially provide images of the Sun's disk in the near ultraviolet for the first time ever. This disk is the outer visible layer of gas and dust surrounding the Sun. One of the mission's tasks is to help scientists figure out how the dynamics within the corona and the Sun's lower atmosphere drive space weather. You see, our star has a massive and pretty complex magnetic field which wanes and strengthens again, reaching its peak every 11 years or so. When it happens, the north and south poles of the field flip. The current cycle is predicted to reach its maximum in 2024 or 2025. It means that solar activity is going to keep rising in the next few years, making this period perfect for collecting data. There are 5 Lagrange points in space where the gravity between 2 bodies, in our case between the Sun and Earth, cancels out. It means that a spaceship can remain there with minimal use of fuel, and L1, which is the goal of Aditya L1, offers a great view of the Sun as a benefit. The Indian space probe is going to join 4 other craft orbiting L1. The satellite is supposed to reach its orbit in the middle of January, and by the end of February, scientists hope to start getting regular reports. The probe is expected to send around 1,440 images per day to the ground station, where these pictures will be analyzed. Aditya L1 isn't the only spacecraft exploring the Sun. Probably the most famous one is NASA's Parker Solar Probe. Its main goal is to touch the Sun. It's flying closer to the surface of our star than any other spacecraft before. Astronomers hope that this mission will revolutionize our understanding of the Sun. For one thing, the distance between the probe and the surface of our star is more than 7 times smaller than that between the Sun and any other spaceship. Plus, over 7 years of hard work, Parker is supposed to complete 24 orbits around the Sun, and at its closest approach, the spacecraft will hang out around 3.9 million miles away from the Sun, which in this situation is very close, and its speed will be about 430,000 miles per hour. If you moved at this same speed, you'd get from Philadelphia to Washington, D.C. in just 1 second. The Parker Solar Probe has its instruments protected from the Sun by a 4.5-inch thick carbon composite shield. It can withstand temperatures of around 2,500 degrees Fahrenheit. But what exactly does the probe do? It dives into the scorching atmosphere of our star, having to withstand insane heat and radiation just to give us a glimpse of what this atmosphere is like. In 2021, NASA announced that the probe had flown through the corona, the Sun's upper atmosphere. Parker managed to take samples of magnetic fields and particles there. It was the first time ever when a spaceship touched the Sun. The probe was designed to travel within 4 million miles of the surface of our star, tracing the flow of energy, studying the heating of the corona, and exploring the acceleration of the solar wind. Hopefully, we'll get the answers to a few long-standing questions, like why is the Sun's corona much hotter than the star's surface? What makes the solar wind accelerate? And what is the source of those high-energy solar particles? It's hard to believe, but we actually live in the Sun's atmosphere. At first sight, our star looks like a bright, self-contained sphere hanging out somewhere far away in space. But that visible edge is just the beginning. The Sun's hot corona reaches way past Earth, all the way to Pluto and even beyond. You can't normally see this corona. It's visible only during a total eclipse, but believe me, it's there. The corona has its own weather. Billion-ton coronal mass ejections occur there. High-energy radiation storms rage from the Sun's upper atmosphere. Relentless solar winds can reach a speed of 1 million miles per hour, and every comet, asteroid, and even planet in the solar system is affected by those elements. The Sun still has a lot of surprises for us. For example, recently, NASA's Solar Dynamics Observatory has discovered a large coronal hole in the southern part of our star's outer atmosphere. The temperature there can reach millions of degrees Fahrenheit. Such giant coronal holes can have a dramatic impact on our planet. They mean that the Sun produces and sends off streams of gas that can easily reach Earth. This can result in geomagnetic storms, triggering disturbances in the atmosphere. At the same time, such solar flares also produce some of the most beautiful phenomena on Earth, the aurora borealis. But since the flares affect our planet's magnetic field, they can have an impact on GPS mapping, satellite television signals, and even cell phone transmission. How bad it gets depends on the intensity of solar flares. Another rather frequent occurrence of this natural phenomenon is power grid outages. Luckily, Earth's magnetic field does a great job protecting us from solar flares. But sometimes, the flares are just too powerful to go unnoticed. Some of them can release 10 million times more energy than the most powerful volcanic eruptions. Within a few minutes, one flare can give out billions of tons of charged particles. Solar flares are also insanely high. Their temperatures can reach several million degrees Fahrenheit. Now, the following news may sound scary, but there are also superflares. In comparison to them, our Sun's bursts of radiation are small potatoes. Superflares mostly occur in young and active stars. In 2016, astronomers saw such a phenomenon. A star 1,500 light-years away from Earth produced a flare that was 10 billion times more powerful than any of those that burst from our Sun. It doesn't mean we're safe here on Earth. Even our middle-aged Sun knows how to produce superflares. But while young stars can have them once a week or even more often, for the Sun, it's once in a few thousand years. And still, if people don't figure out how to protect the planet, just one superflare can shred our ozone layer and wipe out life on Earth. Or not.
Have you ever wondered how the world will go down in flames? Will it be due to zombies, extraterrestrial civilizations, or AI taking over? Nah, turns out it might actually be mosquitoes and scientists causing the chaos. It's funny how things created by nature aren't as threatening as the stuff that doesn't exist naturally. And you know what's on that list? Editing the DNA genome. Experiments with the genetic structure of living organisms can produce completely new species, and no one knows how nature will react to them. Let's look at an example of gene drive. So it all started with malaria mosquitoes. To somehow stop the growth of their population and prevent the spread of malaria, scientists created a gene that magically made mosquitoes only have male offspring. Several insects with this gene transmitted it to others during the mating season, and thus spread infertility. Scientists were able to stop malaria and destroy almost the entire mosquito population. But imagine if something went wrong in the mosquito genome and their population began to increase exponentially. Malaria could spread across all continents and create huge problems for all of us. Now, let's move from the little mosquito problem to a planetary disaster that can be caused by the desire for knowledge, which is deeply embedded in our nature. British cosmologist Martin Rees once said that we lived in the 1st century when human beings could determine the planet's future. It seems that it's so easy not to destroy yourself, but our nature is quite complicated. In pursuit of solving the mysteries of the universe, we have built a giant machine that, according to some people, may destroy our planet. And this device is the Large Hadron Collider. The main task of this giant machine is to accelerate particles and make them collide with one another. Scientists expect that the collider will help better understand the structure of our universe. In simple words, this is a miniature simulator of the universe. Using it may also shed light on the mystery of dark matter. During operation, the machine compresses atoms and makes them crash into one another at great speed. Perhaps this is how our universe appeared. Some people fear that a small black hole may form because of this collision. A tiny particle with a huge weight will pull all objects inside itself. Its mass will grow, but its size won't change much. As a result, it will compress the entire Earth and turn it into a ball measuring a little more than 300 feet across. At the same time, our planet will still have the same weight. A powerful gravitational pull on such a small area of matter can form a black hole that might later swallow up our entire solar system. There are also theories that the Hadron Collider could open a portal to a parallel universe with creepy monsters that would enter our world. But of course, such theories have little to do with science. Scientists have already launched the collider several times, and as you can see, nothing terrible has happened. But there is a small nuance. With each launch, scientists increase the speed of particles. Who knows what will happen when they accelerate them too much? According to Martin Rees, the probability that Earth will become a black hole is very, very small. Particles with a much larger energy charge fly in space faster than in the Hadron Collider, and nothing catastrophic happens. Okay, now let's go back to our genomic games to see what else can happen if we continue experimenting with nature. The main problem might be an imbalance in ecosystems. In the 19th century, sailors accidentally brought mice to Gough Island in the South Atlantic Ocean. Rodents had no dangerous enemies there, so their population began to grow. Mice began to displace dozens of birds from their home. The rodents attacked the chicks and reduced the population of entire species. Trying to save the birds, scientists decided to get rid of the mice, but these little creatures still managed to survive. As a result, the balance of the whole ecosystem was disrupted. Using gene drive to get rid of one species can lead to uncontrolled population growth of another. Imagine that malaria mosquitoes controlled the population of some flies. And what would happen if these flies lost their main natural enemy? The population of these flies would start destroying other species, and it would begin a chain of destructive events. All this suggests that playing with things that don't exist in nature is very dangerous. We worry a lot about how artificial intelligence can take over the world and eliminate us. Still, at the same time, we don't pay attention to our actions. Genome editing can lead to positive consequences, such as the appearance of healthier people, and destructive ones, like the creation of artificial bacteria that can cause serious health problems. In general, destroying other species is a trait inherent in humans. Because of our actions, many animals have disappeared from the face of the earth. Moreover, we even destroy each other. Such aggressive behavior is our nature. And artificial intelligence doesn't have anthropomorphic properties. Its logic may be completely different from ours, and instead of destroying people, it might strive to save them. And we have something to save us from. Remember the giant asteroid that erased more than half of the living creatures on Earth? The fall of the space rock caused a massive blast wave, a tsunami, earthquakes, and dust clouds that covered the sun. Dinosaurs and other animals couldn't survive in such conditions. But what if something similar happens these days? Fortunately, we're better prepared than dinosaurs. Firstly, we have the technology to track giant meteorites and calculate their trajectory. And artificial intelligence can also help us with this. Secondly, we can destroy an asteroid before it reaches us. several powerful rockets will quickly deal with any space rock and turn it into cosmic dust. Moreover, we will know in advance about its approach. But suppose that a huge stone the size of dozens of Everests will fly towards us. In that case, humanity should hurry with Mars colonization. But don't worry. Observing the sky shows that large asteroids capable of causing severe damage to our planet are moving in a different direction. The most giant known asteroid that could collide with Earth might do so in 2088. The probability that it will fall on our planet is 1 in 50,000, so you shouldn't have to worry about threats from outer space. What lies in the bowels of our planet is much more dangerous. Millions of tons of magma and hot gases can burst to the surface through destructive volcanic eruptions. More than 70,000 years ago, a large-scale eruption threw a tremendous amount of ash into the air, which then floated in the atmosphere in the form of a giant gray cloud for a long time. As a result, Earth's surface cooled down by several degrees, which led to one of the most massive extinctions in the history of our planet. Some eruptions happen not only inside volcanoes. There's such a thing as flood basalt. A colossal magma bubble accumulates under a vast area and begins to seep through faults in different parts. Magma slowly goes out there for many years and destroys all living things around. And the worst thing about this situation is that we can't do anything about it. Humanity has learned to track meteorites in space, but we're still not good at predicting a volcano's behavior. Even if we find out that some giant rock will wake up in the next 6 months, there's nothing we can do about that. We won't be able to prevent an eruption. All we can do is evacuate people from dangerous territory. We have no protection against earthquakes, and even more so, we can't stop the emission of ash into the atmosphere. It's possible that artificial intelligence will help us with this in the future, but right now, we're powerless. As you can see, there are several options for the end of the world for humanity, and they're all slightly different from those imposed by pop culture and the media. In the end, is it right to look for threats from space or artificial intelligence? The infinite vasts of the universe hold endless possibilities and secrets. And here's one of the intriguing questions: how life and we as humans would look like on other planets. Imagine a world where the laws of physics, the environment, and the conditions are vastly different from what we're used to. How would we adapt and evolve to survive in these strange new lands? Let's see. Mercury is the closest planet to the Sun and has a thin atmosphere. The temperatures there are extreme, with the day side reaching over 800 degrees Fahrenheit and the night side dropping to negative 290 degrees Fahrenheit. So, what can we do to survive these crazy temperatures and constant solar radiation? Maybe we can magically turn into metal. For example, titanium and platinum can perfectly tolerate high temperatures. But seriously though, there is an option. We could settle underground, where the temperatures aren't so frenzied. If we lived underground, we might evolve with large eyes to better capture light. We might also evolve thicker skin to protect ourselves from the intense radiation. Basically, we have two options: become metal or become moles. Let's move on to Venus. This planet is extremely hostile. First of all, Venus is known for its thick, more toxic than your ex type of atmosphere. The whole planet is covered with carbon dioxide, and its surface is absolutely dry, making it incredibly hot. The average temperature is around 847 degrees Fahrenheit, making it one of the hottest planets in our solar system. Also, don't forget about the crazy pressure. Standing on Venus would be like standing 3,000 feet underwater. Only particular hardy microbes from Earth could survive in such conditions. So, if you want to live on Venus, you might have to become a microbe. But unfortunately, since we're not microbes, we have to wear special gear and equipment to survive there. Maybe we'd have to develop a heat-resistant exoskeleton to protect ourselves, as well as get some new lungs that can filter out the toxic elements in the atmosphere. Let's talk about our favorite red sibling, Mars. The first noticeable change after a few hundred years would be your new skeleton. The gravity on Mars is much weaker than on Earth, so your muscles and bones would shrink. To make up for this difference, you'd have to eat more and probably start going to the gym. Also, you'd have to adapt to the low atmospheric pressure and colder temperatures. You need to retain heat, right? That means you need a thicker layer of body fat. Sorry folks, but on Mars, we might become fatter. Another reason to start working out. Another big change would occur in your skin. Your skin is like a big barrier that protects you from harmful things such as bacteria, UV light, looking totally creepy, and so on. So what would happen to it? Most likely, you would turn orange, due to the carotenoids. Carotenoids are a type of nutrient that you get from foods such as carrots, potatoes, tomatoes, and so on. They protect very well against ultraviolet radiation on Mars. They only have one downside. By eating a lot of pumpkins from the Martian farmers market, you'll gradually start to turn orange. But maybe it's not so bad. Maybe life on Jupiter would be easier. Yeah, no, it has no solid land. This planet is made up of hydrogen and helium and is referred to as a gas giant. You would simply float there, like in a huge cloud. And even if you managed to land and try to walk, it would be like moving through a super thick fog. So how would we evolve there? Firstly, we might become much larger in size to withstand the immense pressures. Secondly, the temperature fluctuations on Jupiter are enormous. The surface is terrifyingly cold and the temperature rises significantly under the outer layers of the atmosphere. Thirdly, if you lived on Jupiter, there would be no verbal language. This gas giant absorbs radio waves, so even if you were speaking, no one would hear you. There would be no music either, so no parties. And what's the point then? Hey, maybe we could communicate with sign language, but that's not so simple either. Jupiter is full of wild winds and storm clouds, so it's unlikely you would be able to see anything. So even if we evolved there in some way, our lives would still not be easy. Before landing on Saturn, you would probably want to check out its iconic rings, but you wouldn't be able to do that because Saturn's rings consist of a bunch of ice particles flying in space, so it would be extremely hard to land. So let's go straight to Saturn itself. At first, it may seem that Saturn is not bad for us. Some layers of this gas giant have quite pleasant temperatures. If we dive deeper into Saturn, it gets surprisingly warm, up to 26 degrees Fahrenheit in its second layer. This is an average temperature in countries like Sweden and Canada. But unfortunately, this is only one such layer. The rest of the planet is incredibly cold, so in order to survive on Saturn, we'd have to do a lot of work. In addition to the cold, we'd have to deal with the planet's harsh environment, including its intense storms, strong winds, and radiation. To protect ourselves from these conditions, we'd need to evolve tough skin, again, find some insulation, and so on. Next planet is Uranus. Uranus has a very different environment from Earth, with much colder temperatures, a lack of a solid surface, and a much different atmosphere. It's like another Jupiter, but with blue vibes. It's not that bad though. There's even water on Uranus. The only problem is, the planet is full of ammonia, that nasty stuff we use for cleaning, so don't be surprised if you feel the gross smell. Also, it's incredibly cold out there, almost like a never-ending winter. So what would it be like to survive in such a dark and harsh environment? We'd need thicker skin, again, to cope with extreme temperatures. And again, we'd need larger eyes to see better in all this darkness. We might even have to develop a new hearing system, like that of dolphins. Wouldn't that be fun? Let's move on to Neptune. If human beings were to evolve on Neptune, they would need to adapt to its harsh conditions. Neptune, the eighth and farthest planet from our Sun, is another gas giant. The only difference is this planet may have a solid core. If we were to live on Neptune, we'd need to float or swim in its methane-rich atmosphere. We'd also need to develop gills or something like that in order to breathe. Basically, we'd turn into space reptiles or cosmic fishes. The gravity on Neptune is slightly stronger than Earth's, but strong winds make it difficult to stand in one place. To withstand the wind, we'd need to be much heavier. Once again, you need to eat a lot and pump up some muscles. Yeah, technically it's not a planet, but we still love it and can't forget it. A small, distant, and incredibly cold world. Pluto's even smaller than our moon, and because of that, there's almost no gravity there. It will be extremely difficult to stand on it. To avoid accidentally flying into outer space while playing football, we need to create a fake gravity machine. And if we don't want to feel dizzy, we need to evolve a brand new nervous system. But Pluto isn't all that bad. For example, there's liquid water under the surface, and even some icy mountains. Maybe it would be possible to survive there if we had some serious equipment, clothes, supplies, and… nah, too much hassle. Anyway, from the scorching heat of Mercury to the freezing temperatures of Neptune, each planet has a unique set of environmental challenges and opportunities for evolution. While we may never truly know what humans would look like on these other worlds, it's exciting to consider the endless possibilities. Never stop looking at the stars and asking these questions.